Hi, everyone. Today I'm doing one of the simplest yet most amazing science experiments, making a metal needle float on water. Steel is way denser than water, but thanks to surface tension, it works. This experiment is surprisingly accurate in showing how surface forces act in fluids, just like in real biological and engineering systems we study in biotransport. Let's get started. Here's the materials I will be using. A small bowl of clean water, a sewing needle, a tiny piece of tissue paper, and lastly, tweezers. Let's start by just trying to float the needle directly on the surface of the water. And as we see, it sinks right away. The needle sinks because it's made of steel, which is denser than water. What's missing here is surface tension. The water surface acts like a thin, stretchy film that resists objects trying to break through. The upward force from this surface tension is given by the equation F equals 2 times gamma time lambda micos, theta, where F is the surface tension force. Gamma is the surface tension of water, around 0.072 newtons per meter, at room temp. L is the length of contact between the water and the needle, and theta is the contact angle. In this case, the angle is at 0 degrees. If this upward force equals or exceeds the weight, the needle can float. At last, one more equation we would be using is W equals mg, where W equals weight, and m equals mass of a needle, which is around 0.45 grams, which would be written as 0.00045 kilograms, and g is the gravitational force of 9.81 meters/second squared. Finally, the pictures on the right show how surface tension helps the needle float and how the water molecules are tightly packed to support it. Now, let's try to make the needle float. I'll use a small piece of tissue paper. As I place on the water, I would gently set the needle on top. As the tissue gets wet, I slide the tissue out of the bowl, and the needle stays floating. You can even see a small concave dip in the water around the needle, but it still floats. That's because the water's surface forms a thin film that holds the needle up. That's surface tension balancing its weight. At last, let's look at the needle is 5 centimeters long and has a mass of 0.45 grams. The weight is W equals 0.00045 times 9.81 equals 0.0044 N. The surface tension force is Fs equals 2 times 0.072 times 0.05 equals 0.0072 N. Since F of the surface is greater than weight, the upward surface tension force is strong enough to hold the needle up, even though the needle is denser. And that's how surface tension allows a metal needle to float on water. Thank you for watching.